I'm Giles Lewis, and today we're going to learn how to export our ServiceNow data to a relational database such as Oracle, MySQL, Postgres, or Microsoft SQL Server. You may have tried using ODBC to access your ServiceNow data and been disappointed with the performance. The problem with the ODBC approach is that it exports data on demand, and the ServiceNow API can be slow when the data volumes are high. What you need to do instead is to maintain a full copy of your ServiceNow data in your external database and then use change data capture to keep that copy updated. So while the initial loading of your external database may take a long time to complete, once you have it, you can keep it updated with just a few minutes of processing each day. There are some commercial products which will do this for you. The most popular one is SnowMirror, but today we're going to solve this problem using open source software that we will download from GitHub. We are going to use a product named SNDML, which stands for ServiceNow Data Mart Loader. The replication engine is written in Java, and the UI is a ServiceNow scoped app named DataPump that we will install in our instance. And in some cases, we may use a mid-server to help manage things. The DataPump app will hold the configuration data for our replication jobs. There will be a bunch of jobs because there are a bunch of tables that we need to replicate, and we will have at least one job for each table. In some cases, we will have multiple jobs for the same table because there will be an initial load which will take a long time to run, and then another job for the same table which we might run daily or hourly to pick up all the changes. For my demo, the ServiceNow instance will be a personal developer instance, and the target database will be Postgres, and I will be running the SNDML Java engine on a Linux VM. We will start by navigating to github.com/gflewis/sndml3. Over here on the left, there's an article getting started with ServiceNow DataPump, which contains much of the same content as in this video. Over here on the right, under Releases, we'll click on Latest. And under Assets, there will be a zip file, which we can download. When we unpack that zip file, we will find an update set shown here in green, which we will use to install the DataPump app. We will also find a set of jar files. You will select the appropriate jar file based on the type of database you have. Let's talk about the connection credentials that we will need for ServiceNow and the database. These credentials are stored in a text file known as the connection profile, which lives on your Linux or Windows VM where it can be accessed by the Java program. You create it with a text editor, and obviously you would secure the permissions of the file since it contains database and ServiceNow passwords. For the database, we will need a JDBC URL, a username, a password, and the name of a schema. This is a demo, so we will call our schema demo. Your JDBC URL will vary based on the type of database you are using, so check your database documentation. You need to make sure that the database schema exists and that this database user has complete access to the schema, because the Java program will be generating create table statements and updating the tables in the schema. You won't necessarily present this particular schema to end users who are doing reporting. I refer to the tables in this schema as raw tables. They just contain copies of the ServiceNow records. For example, they will have sysids instead of display values. You might have a second schema which is used for reporting. Then you would use database views to present the data in a format that is more user-friendly. But that is all beyond the scope of today's demo. Today we are just trying to get the raw data out of ServiceNow and into our database. For ServiceNow, we will use two sets of credentials. The first set of credentials, DataPump Agent, is used by the Java app to talk to the scoped app. As the various jobs are run, the Java app will be updating the status of the jobs in the scoped app. The second set of credentials, DataPump Reader, is used by the Java app to pull your data out of ServiceNow. That second set of credentials can be read-only since the Java engine does not require write access to your data. Both accounts are in the same instance. The instance property can be either a full URL starting with HTTPS, or you can just give the instance name. I'm using a PDI, so my instance is dev plus a 6-digit number. We've now installed the update set in our PDI. If we type DataPump in the filter navigator, we can see a list of modules in the DataPump app. We've also created two users. Here's the DataPump agent user. We've assigned a password, set the time zone to GMT, set web services only, and we've granted this account SNDML daemon role. Here's the DataPump Reader account, also GMT, also web services only. To this account, we've granted idle role, we've granted SNC read-only role, and we've also granted SOAP query. Once we have the accounts created, it's a good idea to run a connectivity test to make sure that the connection profile is correct. I'm here on my Linux VM and I have two files, my connection profile, which is demo.profile, and my jar file. I will type in the following command, java-ea-jar, the name of the jar file, -p, the name of the connection profile, -t. Then I will choose a table which is small, but which has some data in it. I will choose CMN location. We can see that SNDML connects to the database, and it issues a create table statement. Then it loads 427 records. If I run the same command again, then the table will be reloaded, but this time the create table will be missing. When SNDML starts a job, it first checks to see if the table exists in the target schema. If it does not exist, then it creates the table. But if it does exist, then the existing table is used and SNDML matches up the column names. I can see here that there are 427 rows in the table. And here are the names of the first 10 locations. Now let's run the same job using the DataPump app. I'll go to DataPump Agents and create a new agent. The name of this agent is Demo. It's the same as we specified in the connection profile. Then under the agent, I will create a new database table. I'll select CMN location and save this record. Next, I will create a new job. The type of this job will be upsert. And again, I'll save the record. Then I will click the Execute Now button. We can see that a new job run record has been created. The status is ready, but nothing happens. I need to go back to the Linux VM and run the following command, java-ea-jar, the name of the jar file, -p, the name of the connection profile, --scan. This tells the program to look for any jobs that are in a ready state. We can see that the status of the job has changed to running, and 427 records are loaded. Here we can see that the Java program loaded 427 records, and then it terminated. There are several different ways we can run the Java app. We just saw an example of scan. It checks for any jobs that are ready and executes them. When the scan finishes, it checks for any additional jobs that are ready. This is referred to as automatic rescan. Automatic rescan becomes important when we use schedules. We'll see an example of a schedule shortly. On a schedule, the completion of an earlier job can cause a subsequent job to become ready. When that happens, the scan will keep on running until it finds nothing ready. In production, this is typically used when you have a synchronized schedule. Let's say that you do your DataPump exports daily at 5 p.m. So at 5 p.m. you have a schedule that runs in ServiceNow that selects those jobs for execution. Then a couple of minutes after 5, you would use the Windows scheduler, or cron if you were using Linux, to run a scan. That scan will keep running until all the jobs complete. Then the Java program will shut down. Daemon is even simpler. It runs a scan every few minutes, then goes to sleep, wakes up, and tries again. The program runs forever until it is killed. You can set the scan interval using a property in the connection profile. With both scan and daemon, the job will not start running automatically as we saw in the last example. It starts execution when the next scan runs. Version 3.5 adds a server option and an auto start field on the agent form. When the Java program is run with --server, it behaves as an HTTP server and listens for messages on a port that is specified in the connection profile. The auto start field on the agent form is set to server. This causes a business rule to run when the status of a job run record changes to ready. The business rule sends a message to the Java program with a sysID of the record, and the Java program starts running the job. Now normally, in order for this to work, you would need to open up that TCP/IP port on your Linux or Windows VM so that the message can get through, which is okay. But if you don't want to modify the firewall on the VM, there is a workaround, which is to install a mid server on that VM. So here's what that configuration might look like. On the agent record, we have set job run auto start to HTTP server and the port to 5124. But instead of specifying the name or the IP address of the server, we have typed in localhost because it is running on a mid server, and we've given the name of the mid server where it is running. So when that HTTP message goes out, it goes out via the mid server, and the mid server sends the message to port 5124 on localhost. The server port has been specified in the connection profile. Then we run SNDML with --server, and that causes it to listen on port 5124. Now let's run the same job as before using the HTTP server and see how the behavior is different. First, we start the server. It starts up and it's listening on port 5124. Here's our job. Let's click Execute Now. The job run record is created, and we can see that it starts running immediately. It loads 427 records. And here, the server is still running, and it's still listening on port 5124. Let's go over the types of jobs. Upsert is the most common. It updates existing records or inserts new records. If the Since Last box is checked, then it only processes records inserted or updated since the last run. That's from the last run start field on the database table. Insert can be used for the initial loading of tables. It does inserts only, and if the record already exists, then it is ignored. Sometimes people just use the upsert for initial loads if the table is small. There's a truncate box here if you want to truncate the table before the load. Where insert comes in useful is if you are doing a partitioned load. Partitioned load is typically used for large tables, typically task-based tables such as incident. This is a PDI, and there are not any large tables, but here's a screenshot showing results of a partitioned load in another instance. A large table could take a long time to load, so what the partitioned load does is to divide that work up by syscreated date. You can do it by week or by month or by quarter. It loads the most recent partition first, and it gradually works its way back in time. It still takes a long time, but you can at least watch the progress as it runs. There's a threads parameter when you set up a partitioned load, and you can increase your performance somewhat by loading 2 or 3 partitions concurrently. But if you go much higher than that on the number of threads, it creates a traffic jam and you will start to get timeout errors. So in this example, the load was partitioned by month. There were 37 partitions, and the total time for all of those partitions was 4.5 hours. Sync does a comparison of the sys updated on timestamps between the source and target. And from that comparison, it can figure out which records need to be inserted, updated, or deleted. This is obviously going to be a lot slower than upsert since last. Upsert since last just checks recently updated records, whereas sync has to check everything. For most tables, we don't care about deletes because they don't happen or they don't happen very often. So one strategy is to do an upsert every day or even every hour and then do a sync once a week to pick up the deletes. But for some tables, like sysuser_gr_member, you will have lots of deletes, so you may want to do a sync once a day. Last of all is execute, which is used to execute a stored procedure in the target database, typically following a load. Our last topic is schedules. Here is a simple schedule with several jobs. Setting up a schedule is a multi-step process. First, you create a bunch of jobs, then you create an empty schedule. Then you can edit the jobs and put them in the schedule. Then you can use this form to reorder the jobs. This table inherits from the out-of-box scheduled script execution, so you can set the schedule to run daily or weekly or hourly or whenever you want. You can use the Execute Now button to test the schedule. When you have a schedule, the order number of the jobs becomes important. In this example, the location and the department tables will be updated first, and those two jobs will run concurrently because they have the same order number. After all the 100 jobs finish, we will run the 200 job, which is a sysuser update. Then, after the 200 job finishes, we will run the 300 job, which is a sync of sysuser_gr_member. I hope you have found this video to be helpful. Here is the URL to get more information about the DataPump app. Please give this video a thumbs up, and if you are using the app and have had success with it, then leave a comment. If you have questions, problems, or suggestions, then please open an issue on the GitHub Issues page so that your question can be addressed.